even if we have some breaks, we usually go to meet each other at some bar. So Discord is a place to go if you want to be up to date with what's going on, what's happening, because we are constantly letting you know when something happens. This is second QR code. Now the competition, go to Discord, and on the Discord, as far as I remember, this is the competition, right, guys? On the Discord, we have a channel dedicated to this meeting. Post some new things you have learned recently, some ideas, some new libraries you have found out recently, or you have used and you want to share with other people. Gather as many emojis as you can under your post, and the person with most of them will get the software license from JetBrains. If you don't remember, it's discord.pykonik.org. So join us there. Okay. After today, after the 4 presentations and the lightning talks we'll have, we will go to Filutech together, and we can sit down and talk much more on the topics that all of us love to discuss. And it's not necessarily always only Python, but all the technologies that we use. All right, so this is Tech Talks 79. And we'll start with the first presentation in a few minutes. So Władek, come to the stage and let's go. So give us like a minute just to switch the computers and we'll start. Władek, and the stage is yours.
Thank you. Oh, can you hear me well? Okay. So my name is Władek, and today I'm going to talk about the technical challenges of building MCP client. So nobody can deny the AI revolution, and no tech company wants to lag behind. Everyone wants to get aboard the AI tech hype train as fast as possible. And arguably, the easiest way to do so is to build your own MCP server, because you basically can apply all the engineering principles and knowledge you learned so far to this domain without being AI expert or AI engineer or whatever. So basically, what is MCP? In short, I like to think of it as an abstraction or a layer of direction between the applications running or accessing large language models and services which provide tooling to extend the functionality of those applications with large language models. Like the ecosystem is growing really fast. One of the most recent additions is MCP registry specification, which like allows for discoverability of various MCP servers. And you can think of it basically as an app store for MCP servers. So the question is, how do you actually connect to an MCP server? Well, for it, you need an MCP client application. And I believe all of us at least heard or used some of those. In fact, Anthropic even keeps like a reference list of example MCP clients on their main page. And you can take a look. And one noticeable thing is that most of these applications are actually either CLI desktop applications or libraries in specific languages which you can use to access model context protocol servers. And rarely there is a remote application which like allows for the same thing. So what is actually a remote MCP client then? Well, first of all, it runs on separate infrastructure. You can serve multiple users simultaneously, and you can connect to multiple MCP servers at the same time. And a great example of such a client is Cloud.ai. They call their MCP servers connectors, and each connector is essentially an instance of MCP client if you like being really strict. And you can even bring your own one. And well, whereas there are like a lot of remote MCP clients, when you go to MCP documentation, you can navigate to a sub-page called Build an MCP Client, where Anthropic will go like walk you through how to build your own MCP client using SDKs in the languages they support. And it looks almost like Anthropic doesn't want people to build remote MCP clients, because all they show you is how to run like those sub-processes for local Python files or JavaScript. I started digging a bit deeper, and I discovered a repository in official model context protocol GitHub organization called example remote client. And it's constantly marked as work in progress, but I started digging deeper. And one interesting file is actually this one, the connection.ts, in which you can see that basically all the remote part of this client ends when all the data is being stored in local storage. But anyways, we can learn a lot from this example, and we will see why next. So the question is then, what do we actually need to build a remote MCP client? First of all, we need some way to store the configuration for MCP servers. And like largely adopted format so far is to use some form of JSON, where you either provide a command to be run as a sub-process, then you just communicate with it using standard input and standard output, or you provide a single URL. Then the client would know that you are trying to connect to the remote MCP server. And if we are to build one, what tooling do we actually have? Well, the most popular one, I would say, is FastMCP. It's a great tool to build both MCP servers and MCP clients. There is MCP use, which is also kind of popular. It's more like configuration-driven. You can also build some agents using MCP servers as their toolset. And the last one, which is in my opinion, is the preferable one, is Pydantic.ai, but it's like more focused on building agents using like MCP servers as their toolset. So it's not like for programmatic access to MCP servers. And of course, you can always use the official Python MCP SDK for maximum control. But, well, we have a lot of tools. Those are only three that I picked. But, yeah, they are all great for local client development, but they fall short for remote one, and even the official SDK. And the main point is actual authorization part. Because like we need to be able to authorize users separately and keep their connections, like keep the state, refresh connections, and so on. So, like, let me do a quick introduction to MCP authorization protocols. We are basically on the same page. This part is probably outdated as for now, because today I discovered that the new revision of MCP protocol has been released as of 25th of November. But still, those parts are still in place, so it's still useful, but a bit more simplistic to the current state of art. So as of March this year, Anthropic officially adopted OAuth 2.1 as a supported method for authorization in MCP servers. So clients and MCP servers should use this one if they are implementing any kind of MCP authorization. And as of June this year, they clearly separated MCP servers as protected resource servers and authorization servers actually issuing tokens and performing all the authorization part. And there are 4 components involved, basically. The first one is proof key for code exchange to prevent authorization code injections and cross-site resource forgery attacks. There is metadata discovery, where the client can automatically learn what authorization server it should use and what scopes are available, and basically all the necessary data. There is dynamic client registration, so the client doesn't need to be pre-registered beforehand. For example, with common authorization providers like Google, you need to create a client, to get client ID, client secret, and so on, before you actually start using those providers. And yeah, basically a repetition of what I said, they clearly separated the server from authorization server. Yeah, so in the most simplistic way, greatly simplifying, the authorization flow for MCP servers looks as follows. You just make one unauthorized request to the server, and you learn from the www authenticate header in response what endpoint should you call to learn to get the protected resource metadata JSON. From that JSON, you discover basically what authorization servers are available to you, what scopes are supported, and you pick an authorization server, and subsequently discovering the metadata for that authorization server, which give you the authorization endpoint, token endpoint, registration endpoint, if the provider supports dynamic client registration, and so on. When you learn all of that, when you actually do dynamic client registration using the registration endpoint, where you provide the metadata for your client you're building. And in the end, you just redirect the user to the authorized endpoint, providing the resource parameter and code challenge and all the necessary data for OAuth 2. And hopefully, you're being redirected back to your callback endpoint with authorization code, which you following exchange to an access token for a given user. And using this access token, you're now basically entitled to perform all the necessary steps to initialize the connection, to call the tools, get the prompts, get the resources, and so on. And the fact that all of it, the entire MCP authorization framework builds upon standard protocols, allows to you, as a developer, to write code like this, where you basically provide auth is equal auth, and the client knows what it has to do step by step to get necessary metadata and perform all this stuff. And you may be wondering, then what's the catch if that's so simple and deterministic? Well, the catch is actually the official SDK. And if you take a closer look, you will notice that there are basically 3 classes that are interesting to use. One is an abstraction to token storage, and auth client provider, which actually derives from httpx.auth. But that doesn't matter. What matters is that you need to provide redirect handler and callback handler, and MCP SDK expects you to perform the entire authentication flow in a single process, waiting for each stage to be finished. So you're doing all the metadata discovery, you're registering the client, you're redirecting the user to the authorization endpoint, and then you're waiting for the redirection, for the callback request to be performed, and awaiting it with the callback handler. So all of it is happening in a single loop, which is falling completely short for local client development. So the main problem, it works nice for libraries like FastMCP because they just use this class in the redirection handler there. They just open the browser and navigate the user to the authorization URL. And for the callback handler, they just spin up server listening on some port in the same process. So it's really simple. But again, it fails to meet the needs of remote clients. And well, so what are basically the needs of the remote clients? First of all, as I mentioned, they need to be able to redirect the users to authorization URL and asynchronously handle the authorization callbacks, like performed by the external identity providers. So those like 2 steps might happen completely asynchronously on different servers, on different infrastructure, on different machines, whatever. Like it doesn't matter. And you need to account for the distributed nature. You need some way to coordinate like the steps where like just indefinite latency in between them. Well, and for that you need some way to persist the state. Well, basically you need 2 parts to persist. First of all is the code verifier for proof key of code exchange. And the second one is session state if you are using it to like associate the callback with the end user or to prevent CSRF attacks as well. Yeah, basically once you receive the tokens for the users or once you register your client dynamically with the identity provider, you're basically granted some sensitive data, including client ID and client secret, and you need some way to like securely store this data, to securely operate it, and at least you can do is to implement some kind of encryption at rest, but you need to think about like sensitive data handling strategy beforehand. I was showing you that optionally some identity providers can support dynamic client registration. And most tutorials you will find on the internet would just register the client as a public one, so they would use the token authentication method as none, which is not very suitable for like server-to-server communication. Basically, if you're building a remote client, you're building a confidential OS2 client. So if the authorization server supports it, you should be using some way to authenticate your request against the token endpoints. And 2 most popular ones are basically client secret post and client secret basic. But of course, there are many more. Well, yeah, and once you're granted the access token for a given user, you need some way to like constantly manage it. First of all, you need to request as little scopes as you need. Of course, there are some issues with scopes, like when you request too little scopes, and as far as I understand, the latest revision of MCP protocol actually addresses this part. But you need to also account for how would you discover the scopes you need to request and how would you handle token reversion, because users wouldn't want to like reconnect the server from the client all the time. You need some way to be able to automatically refresh the stale tokens using the refresh tokens that you are granted. So in summary, whilst like most tutorials on building MCP clients seem like stupidly simple, in fact, building a remote MCP client is equal to building a secure and reliable OS2.1 client. And MCP SDK is not really suitable for that use case. So you will need to account for asynchronous authentication flow. You will need to think about secure state persistence and secure token storage. And you will be wanting to implement some kind of token lifecycle management. And that would be it from my side. Thanks a lot.
Hello. It's time for questions. Before I will pass the microphone to the first one, I wanted to remind you that you can also ask in the Discord channel questions, and you can ask also in the YouTube stream if you are shy, even if you are in the room. So, first question. I see one.
Very general question. Are there any materials that you recommend to start learning more about MCP? Any guidance for someone who's taking first steps in that area?
Yeah, for sure. First of all, I highly recommend reading the official documentation, the specification part. They constantly update it. I discovered that they added a sub-page for understanding authorization part of MCP protocol or something like that. I mean, reading through the code of MCP SDK really helped because I mean, you don't want to implement the OS 2.1 from scratch, but sometimes it helps to understand how it actually works. Just basically look at the code.
Okay. Any more questions? I'm looking at the channel. I see someone writing, but I don't think it's going to be a question, probably. So thank you very much once again. Big round of applause. Yeah. Give us 2 minutes to switch the computers. Myślę, że możesz na tym położyć po prostu. Okay, big round of applause.
Enough? Yes? Okay, good. So that's the first thing that I wanted to address, first of all. Maybe let that run in the background, maybe a little bit of introduction. I'm Maciej. I'm actually working here in this building pretty much every day. I'm teaching AI, machine learning, Python, and stuff like this, and also I do research regarding AI and physics. And also I'm doing a lot of stuff with AI, and this is about a little problem that I encountered that made me feel like a mad scientist, and there must be an easier way. Maybe that's the only way to do this thing, but if you know easier way, let me know. So the topic is, it's a stream. And yeah, it sounds like a reference to Frankenstein, because it is, but also because it's the name of the method. It's not like it's just a pun of alive. It's actual method in LangChain and LangGraph. So maybe let's talk a little bit more about LangChain and LangGraph. They are exposing multiple methods internally, and some of them have A at the beginning, which means that this is asynchronous, which sounds great, right? So we'll have a small example here that I will be working on. The idea here for this toy project that we'll use is that we want to have a recommendation for books given a certain topic, and we want to be sure before we will output the list of the recommendations if this is in our library or in store, whatever works. So how does it work? First, we will ask a large language model to generate ideas as ND-JSON. Why ND-JSON? Because, well, it's a format of text data, and we would like to check whether those books are in store. So we need to somehow have some structure in this data to be able to check whether this is in our store to run some functions. And then we return the list of suggestions. Sounds easy. Okay. I have a lot of code. We will have to increase the font size to make that readable. Is it readable, or once more? A bit more? Let's see if that will be too much. I can work with this. Let's start with a simple example here. Here, what we have is LangChain, very, very, very basic example of LangChain. We are creating a chat here. We are saving it to this variable. We have a prompt here that says answer this question, and here we will input the question that we have, and return a list of book recommendations in ND-JSON format. Each line should be a valid JSON object with title and some attributes. So what do? We get this LLM, we input prompt, and we go with it, right? Here we are just taking from the input the query. And then there is a little bit of mumbo jumbo going on with getting attributes, checking the instances. Does anyone know why we are doing those things? Has anyone encountered this problem? No, because generally speaking, output from LangChain is of not deterministic type. They don't have a single type that they are returning every time. You may encounter pretty much anything as a dict. So you need to make sure that this actually parses correctly. And what is even worse, Depending on the chatbot that you are using, the stream type can change. And also it can change if you are changing between, I think, asynchronous and synchronous method, and also between the types of call. You can have stream or invoke. This also changes. So there is no one way to get things from a function in a LangChain. Okay. That needs enhancement as well. I think that should probably be enough. Okay, so let's run UV, run main, simple, Py. What kind of books are you looking for? Let's say James Bond, right? And we have streaming, right? It's working. It's LLM. Tokens go brrr, so that's great. Okay, but we have list of JSON, but we are not sure whether this is something that we can read if it's in our store or in our library, right? So we should definitely introduce here a check. Maybe I will skip one level here. We should introduce a check whether we have it in our store. So now what we'll do is we'll use LangChain, essentially langgraph. Langgraph is like LangChain because LangChain is just calling multiple functions and chaining them. Langgraph allows you to build graphs. So this is what we'll do. We will do this maybe from the end. We are building graph like this. We have call LLM, entity, parse books, process books, and we are joining those edges, nodes, with edges like this. And we are creating a graph like that. It's not too complicated graph. It's very simple graph. It actually looks like this. So we have start, we have call LLMs, we have parse books, process books. What's inside those functions? So process books, what it does is essentially if there is not a field present, then it will add empty field. And at random, because I didn't want to implement any kind of checks, but assume like this is a call to database or something like this. At random, we'll assign it a mark if it's in store or it is not in store. So we have call LLM. Call LLM does pretty much the same as in previous example, and there is this mumbo jumbo that's going on with getting information from a stream. And we are responding with content. We are gluing all of this stuff together into a string, and then we are parsing this book. Sorry, we are parsing this response. So what we want is split it into lines at get JSON, and then we are processing all of that. So each book, we are processing each output. And we get some output in the end. And nothing really interesting is happening here. Let's see how that works. This was Medium, right? Not Python, but UV run. Let's say James Bond. Streaming recommendations. It doesn't work. Nothing is happening. That's awful. No, it works, but it works slow. So this is not LLM. Like probably a marketing team of some sorts would say that this is absolutely unusable because you have to wait a little bit. Why do we have to wait? Because we need to parse this stuff. We need to parse this JSON when we are getting the response. What we could do next is, where do we have it? I think it's saved here. How can we work with this is we can actually get a token by token stream from the LLM and piece it together. And when every token is upcoming, we can check whether it matches our, in this case, regular expression, if it fits JSON. And then we put JSON. But we cannot return it. In the previous example, here, where do we have it? Here. You can notice that all of those methods that are then turned into nodes, call LLM, parse books, returns, right? So when we exit this function, the context of this function is gone. So, and we cannot use yield here. So essentially, all of this graph is asynchronous, yes, but it's called only once, and all of the edges are called only once. So this is the conundrum that I had, and it feels like a hack. It feels literally like creating a Frankenstein monster, because we are creating a graph here, and what we are having is asynchronous stream and queue. We parse those objects coming directly from the LLM, and we put them into queue. And in the meantime, the assumption is that this piece, this buffer, which is buffer of the whole string that LLM is outputting, in the meantime, it will continue to grow, right? While this object will be processed further. So maybe I will just explain how this whole graph looks. We have start stream, we have next item, we have consume item, and we have end, but also there is a connection going back. So let's start with explaining that again. We have start stream, we have next item, consume item, and we have conditional edges in langgraph. Conditional edge in this case means that the connection between the consume item and the next edge, which is either next item, between consume item and next item, it should either result with end or next item, when you go from this, you either go here to next item or to end. So let's see what's going on in conditional end, which is exactly this function. We check whether this state contains done. If it doesn't contain done, we are returning back. So we are just choosing where to go. And consume item, what consume item does, it takes in the state. If the state is done, then it returns just this dict. If it's not done, it returns an item and false value to done. And what is in next item? In next item, we have the queue, the very same queue that we are creating here. And we get next item from this queue. We are processing it. When we process it, we return it like this. And only because of that, only because we have a queue here, and we are getting through it here, and we are returning stuff constantly. Do we have, how much time do we have? 7 minutes. Okay, yeah, that's a lot of time. Okay. Is this working? And we'll have a stream. Maybe I will show this and then explain a little bit more. Well, UV run, sorry. Let's say James Bond. And now we are getting JSON by JSON recommendation, and you can see that this attribute here is in store, is assigned. But we are still getting this object by object. It's not a stream token by token because we need to wait until one of the objects ends in order to be able to process it. And we are processing it exactly the same way. We are assigning it an X with 25% chance to mark if it's in store. Because otherwise, we wouldn't be able to call this function to check, to do this check without a proper one object, and we need to wait until the LLM finishes creating this object to be able to check it. And then in the meantime, the LLM is still continuing to give us tokens. So it would be nice not to stop everything and just wait for the call. And this is how I am doing this problem. I don't know, maybe there is a better way to do that. Maybe this is a bad idea. And generally speaking, I thought that if there are asynchronous methods in langgraph, then we would have something that would be able to work continuously with the stream, but apparently not. And an idea for this talk was because of the last, I think, Pykonik Tech Talks, where there was also a talk about LangChain and LLMs and streaming specifically. And I think that's it from my side.
Questions? Yes. Questions? I haven't seen any on...
There is actually one.
Okay.
Ile postaci z filmów / seriali da się skojarzyć z LLM-ami?
Wszystkie. No. No further questions?
I see.
If you have a better way of doing this, please tell me. I would love to hear.
Okay, I have one question about the LLM in this example. What's the LLM that you pass, and does it work the way that every kind of LLM would support astream, or?
Yes, pretty much yes, because what they are doing, they are streaming with HTTP, like very basic stream, and all of the LLMs, I think, support streaming. So astream, I didn't go into details how the implementation looks like inside. They just claim that this is asynchronous streaming. But how does it work inside? I'm not sure. I assume they are just waiting for another token in this case.
Thank you. One more.
I can ask one more very basic question. You're using Sonnet in this example. If you use something like Opus, which is slower, does it make any difference? If, like, for example, thinks a lot before it provides the response?
I didn't try it, but still my point is to do everything as fast as possible. And this is why I wanted to keep doing this stuff in LangChain, because it already has asynchronous stream implemented, and I assume that other stuff should be working like this. I didn't do tests whether it actually is speeding up stuff.
I have one completely different question. What do you think about using this with like the diffusion text models, where you need to generate like the entire page? I'm assuming something like this would not work because you still need to generate the full output first.
No, I mean all of this and all of those examples, and I think pretty much all of us right now are accustomed to having a text being streamed like this coming in. So I know from my experience that if people see that there is a wall of text that suddenly appears, it doesn't feel right? Because, well, it doesn't feel like it's AI pretty much. So no, this probably wouldn't work.
Any last question? I see none. All right, big round of applause. Thank you. Let's have a 5 minutes of break now, and we'll go with another presentation. So it's the moment to stretch your legs, walk a little bit, talk to other people, and people on the stream also can do that in the rooms wherever they are. So see you in 5 minutes. All right. Quick query. Who's going to after party to Philotech after this meeting? Yeah, let's go. Cool. That's nice. Now, lightning talks. Who's got lightning talk? Oh, one more there. One more here. Okay. I will start doing list in my memory. Mind memory. Okay, we ready?
I think we are, but I'm offline and I wanted to do a demo.
Okay. Few more preparations. Everyone's got a tag. You have your names. More people have names. Yes, positive attitude. Almost. Yep. Wait, I'll help you. Almost. Yes. Moving windows between screens is not easy. From this distance, yes.
Oh, it likes the bar, I guess. Oh, no, it's gone.
Okay. Okay, so we're moving to Django now. And please welcome to the stage, Szymon, who will tell you about user-defined fields.
Yep. Thank you. So, I have some goals for this talk. And unfortunately, there are some prerequisites. The goals is to tell you how we build a production-ready user-defined field system. The goal is for you to understand the problems that we're solving at each step. So if there are any questions, anything is unclear, feel free to interrupt and feel free to ask the questions. I will try to show alternative paths. Some of them are definitely bad, and I will try to explain why we didn't take them. Some of them might work even better than what we have, so we can also discuss those. Again, if you have some experience with similar problems, alternative solutions, feel free to raise your hand, interrupt, and let's have a conversation. And yeah, you should walk away with practical, reusable knowledge. And the prerequisites, of course, some knowledge of Python and Django is needed. But again, if there are any questions, if this is some of the topics are new to someone, feel free to interrupt. I'm pretty sure you will not be the only person that doesn't know something. There is, if one person doesn't know something, probably 10 people don't know, but 9 are too shy to ask. So feel free to raise your hand and interrupt at any time. But back to the problem. What's the problem that we're trying to solve? What is the user-defined fields? I think the font is a little small, but yeah, if it's too small, then come closer and sit closer. There is plenty of seats. Yeah, the real story, I think, not applying only to our company, but to multiple SaaS companies. First, we had a tiny product, which is one size fits all. Questions? Okay, better? I like this. Thanks. Yeah. Any questions, raise your hand. So yeah, the one size fits all means we have a software. We're building legal tech solutions. So lawyers are using our system to run their cases. Some fields are there, some fields are not there. There is a field called notes as everywhere, and their process has to align with what is available in the system, or it will not work. And this is, of course, problematic because every company has their own processes, wants their own fields, their own information stored in the system, and we can't fit every single client into one solution. So phase 2, custom columns, the simplest solution. We need lawyers run cases, right? And in some cases, they need a specific date. In some cases, they need priority. So a big client comes and says, now I need priority of my cases. And we quickly build functionality in the system to add a column, right? Priority, every case now has a priority. But now every user has a priority. Maybe priority, it's fine, but it becomes this date and client shoe size and this and that and weird stuff. And the problem that we started seeing is the forms became gigantic for every company. The big clients, of course, they have a lot of information, a lot of detailed processes, and they needed it. But solo lawyer, like single person office, had exactly the same forms, exactly the same fields, exactly the same gigantic screens. So this was a really bad user experience. And this is where user-defined fields come. So user-defined fields is a way for the user to define what kind of fields do they want to see. Do they want customer's shoe size, customer's phone number, maybe case priority, whatever they want. They can just configure it in the system, and it's personal only to them, right? So other clients don't have to see it, only they see it in their own forms and on their own screens. So really nice way of customizing this the user experience in the system. So the problem with traditional approach, which is called entity attribute value. So if you know SQL, this is the normal form. We divide the data that we want to store into the smallest atomic elements, and we can create 3 separate tables. Entity is the thing that we want to add the fields to. Attribute, we define what field do we want, and value is value of this field. This is scalable, kind of. We will get to the problems. The biggest problem with this naive solution is the query complexity. So to be able to, for one entity, fetch 10, 20, 30 different fields, it's not that easy, right? We can either, if our entity is a customer, for example, then if for each customer we have 10 different attributes, then we have to either join it 10 times to get 10 attributes, or we need to be smart with group bys or do some Python post-processing. The complexity of fetching this data and performance is not really good. And type safety also doesn't work, right? If we store all values in one gigantic table of all values, and the value is whatever we pick, probably string, so everything is serialized to string, and we lose it. And of course, indexing is extremely difficult. In some cases, this is fine if we want to search by a single attribute, but if you want to search by 10 different attributes, it becomes unmaintainable. So explaining a little bit about this query complexity in this case, we can go with a very naive query, right? Just join every single field to the object that we want, and this, as a result from the database, this will be very nice because we will get one column for every single custom field that we have in the database. The problem is the query gets pretty large. There is a nicer solution, the pivot query, where if we group by the entity, we can do this hack where we select maximum value of each custom field. And since each field will have exactly one value for exactly one entity, right? One client will have only one shoe size. Then if we group by client, there should be exactly one shoe size. Doesn't matter how many other fields we have, there will be exactly one shoe size. So however we aggregate it, we can aggregate by max or pretty much any. There will be only one shoe size. So if we aggregate each one, then we will get we will not have to do manually join with for every single field. But still, this is pretty terrible performance-wise in the database, and Django, as far as I know, doesn't support this. So we would have to do subquery for every single subquery for every single field, and then the query becomes gigantic, and in general it's problematic. And still keep in mind that this is shared infrastructure, or the system is shared between different offices, right? So one office has 20 fields, second client has 10 fields, another client has 17, yet another client has 5 more. And now we're not a single client will have 1,000 fields, but given 100 clients, we will definitely have a couple thousand fields in the system. So this solution is a bad idea. It's not maintainable. And that's why we decided to go with HStore. The more modern version would be JSONB. The entire idea of this is to use a database function that will allow us to store semi-structured data in SQL database. So usually in SQL we have one field, one column, one value, right? The table is very normalized. But these two extensions to Postgres, HStore and JSONB, allow us to store kind of NoSQL documents inside of a single column of a SQL database, and treat those values just like nested tables, but be able to query them with normal SQL and normal SQL queries. So on the example, I don't think I have a pointer. I do have a pointer. In the example, you can see if we create a column with user-defined fields as HStore, then both priority and incident date will be stored inside of exactly the same table in the database. And the database will understand how to query those nested values. There are some caveats that we will get back to, but let's talk about. For now, let's assume that this is sounds like a perfect solution, exactly what we want to do, right? One entity can have multiple values, and of course, those values don't have to be exactly the same for every single record in the database, right? One guy can have priority, the other guy can have something else in place of priority, yet someone else can have completely empty, no custom fields, no information in here. So it sounds like something exactly a perfect solution to the problem that we have. So digging into HStore a little bit deeper, we decided to use HStore. So let's see in more details how it works. It looks like a perfect solution. There is one big problem. The keys and the values are stored in the database as strings. So we are losing the type information. If we store value 1, then it's a string 1 in quotes, right? Which might be problematic a little, but they are stored internally in a very efficient form in the database. This field supports indexing, so it's really nice to work with. And just looking at the raw SQL, this is fully supported, nice feature of the database. Defining the column is very easy. We just say that it's HStore. We just say that this is HStore column, and then when inserting data, we can just insert like with a very readable and nice syntax. And this is of course supported by Django. So on the next screens you will see how Django handles it. But from SQL perspective, it's super nice to work with. If we were implementing this feature today, I think we should choose different type of storage in the database. We should choose JSONB. There is some differences. The biggest one is the typing. So as I said, HStore is everything is stored as strings. So keys and values are serialized to a string, and JSONB knows about types and can serialize the types and deserialize the types correctly. Second difference is nesting. HStore doesn't have any nesting. It's just key value store, and inside of the value, well, you can always serialize JSON to string and dump it in there, right? But that's exactly the point of how to build it, because then how do you query it, right? The entire point is to be able to query, to sort, to filter by those user-defined fields. And of course, JSON-B, like JSON, supports nesting. In our case, this nesting is not really important. We want users to be able to just store fields, not very complex types, but it might be a factor. It used to be, there is some tiny performance difference, but it was fixed. And from what I've seen, I haven't tested it on Postgres 14, but I've heard that in Postgres 14 there is no performance difference. It even supports more types of indexes. So JSON-B is probably a way to go, but we implemented it a couple years ago, and the system was running on even older Postgres database. I think the Postgres that we had on production back then was from year 2000-ish. So there still was some different indexes supported and the database size. So we went with HStore, which required some extra work in Python to work on the types. I think the typing in Python is still needed, and some of this work would still be necessary, but it's better to be safe than sorry, and it's better if Postgres checks for you. If you say that there should be an integer in the shoe size, then it should be integer and not XL. Maybe your validation might be broken, and it's better if the database checks that for you. So yeah, I think rest of the talk still applies to JSON-B in exactly the same way. Beware, but it works in HStore very well in production for years. No problems with that. So both are fine, I think. Okay, so we spoke about storing this stuff in the database. And now the tricky part is we want this data indexed, right? Want to be able to query it quickly, to be able to sort, to be able to filter, to have a nice performance. So small sidestep about indices in the database. Who here knows how indices in the? Maybe I shouldn't be showing this slide. Yeah, who knows how gene index works in Postgres database? Okay, so if you have any questions, ask. I'll be happy to answer, explain more if I'm skipping over something too quickly. Seriously, feel free. I think we have some time. But yeah, indexing. So we want this, the entire idea why we're not just dumping strings as they are into this magic column, because we could just serialize all the values, right? Put them to JSON, like to a JSON string, and then save the string in a string column in the database, and it would work, except we would not be able to query this data very quickly. So the idea with indexing is that on the left is a representation of what we store in the database, right? And row number 1 is something with a high priority, row number 2 is low priority, row number 3 has both of those fields. And now without the index, and this is not something that happens by default either in HStore or in JSON-B, you have to enable indexing. Indexing means Postgres internally is building a second lookup table that is reversed, right? So for priority high, it stores which rows are priority high. For priority low, it stores which rows are priority low. And in this way, we can look up rows very quickly. And there is a minus of having too many indices, which is of course memory, right? Indices to be performant need to live in memory, and if you index every single field, then all the indices will not fit in the database memory, and once they get dumped on the disk and you have to read files from disk to access the data, the indices are not really useful because you could just read the table from the disk and find what you need, right? So there is some trade-off, but usually the indices are much smaller than the actual data that they store, and they are a good idea. So for HStore and for JSON-B, the gene index is pretty much something that you enable, and it just works. You just create index on the table using gene and the column name that we want to have indexed. If you're doing this on production, it might be a good idea to add a magic keyword concurrently. I'm not sure why this is not enabled by default, but just runs faster, so less downtime during deployment. But pretty simple, and once you enable this index, then the database queries are working fast, and it's again going into the fields, the HStore fields. It's very pleasant. You can see the syntax. It contains some weird characters and some quoting, but doesn't require any magic. And Django ORM is really good with writing those queries. Okay, another tangent. There is a second piece to this puzzle to be able to implement it correctly, and it's Django content type framework. Who knows what is content type framework in Django? Couple people. Okay, so everything clear about the indices? Any questions? Anything that I got wrong and should be corrected? No? Okay, so content type framework. The idea is we want to make one implementation of the user-defined fields system, right? And we want it to work on multiple models. We don't want separate user-defined fields on cases and separate on clients and separate on invoices and separate on what not. We want one system of user-defined fields that will support multiple models. And to be able to support multiple models, we can use Django content type framework, which is a registry of all models stored in the database. And there is a nice mechanism in Django that can allow us pretty much convert a string into model instance and into model definition class, and the other way around, class into a string that is stored in the database. So if we want to have some implementation of a functionality that will work across multiple models in Django application, content types is the thing that we probably want to use. So now I think, is it clear? Any questions? No. Okay. So I think we're ready to talk about how do we want to define the user-defined fields, and this will be in a user definition, UDF definition class, which is of course a model in the database. And looking for my pointer. The most important things is inside of it. We want to store double label, right? So what the user types in when he creates the field. We need to store the field type partially because of HStore doesn't know the type for us, so we need to track the types, and partially because on the front end we probably want to show a different input widget depending if it's a date or time or string or long text. So we want to know what type of it is, and a slug which will be inside of the. Let me go back. Inside of the table, we need the key and value. The key, of course, cannot be directly taken from what the user calls the field, right? We can't use the display label as the key, so we need some form of internal key, nice label, and the value and the type which we need to track on our own. And of course, there is a bunch of additional metadata. When user creates this his own field, we can track is it required. We can track who created it, when, what's the default ordering, and of course, as I said, this is per client's office. So office ID and who even can see a specific field, right? Because now different offices can see different fields. So we need all of this information. And in Python, to be able to work with it nicely, we can create an enum that will represent all the types that we support so far. So going back to this to this internal slug or the key in key value store that will be used to represent the fields. The easiest solution is just throw a UID in there, right? And it will be stored and indexed UID. We decided to go with human readable slugs, and I definitely recommend this kind of solution in multiple places just for human debuggability, right? You're able to go into the database, look at the internal, or in Django, look at an internal representation of this key value store, and you can see which keys and which values are corresponding to each other in a human readable way, right? If we have field that is called shoe size, then we can see it's shoe underscore size, and if shoe size is -1, then we know we have a problem. If some random long string is -1, then it's not that clear where the problem is. The only tricky part is it, of course, be unique. So there is a unique suffix and unique suffix generator that makes the fields unique and human readable at the same time. Of course, we can't guarantee the uniqueness. So every time we try to create it opportunistically, it's not in the code, but we try to create it opportunistically. And every once in a million there is a conflict, then we'll just retry with a different suffix. So no super tricky algorithms, super useful and very nice for debugging. Definitely recommended for multiple situations where you can skip using UIDs. Super useful tip. Okay, so the last problem is typing, right? In the database, everything will be stored as a string, and we don't like that. We don't like that because of problems with sorting. Can you see my pointer when it's here? Oh, nice. Yes. So we don't like it because of problems with sorting, and of course we don't like it because of problems with working with this data in Python later. So we need to handle this on our own. The JSON-B would probably make this slide not necessary. At least the part on the right would not be necessary, because we need to implement our own serializer and deserializer, where explicitly for every single type of the data that we want to store, we will serialize it to database, which means serialize it to string, and then deserialize it from the database to a correct Python object, and also handle errors and log warnings if it goes wrong. So this we actually needed to implement manually, but still the enum on the left, we will need this one because, again, we want to show nice widgets for the user. So we still want to know that date is date and it needs a date picker, and integer is a number, it needs a number kind of front-end widget. So we have the entire flow. We spoke about the entire flow. Now it's time to show you how it works. Let's see. So this looks like a production system, but it's not a production system. Any data that you see in here is completely fake and randomly generated, might contain weird and stupid tests. If you see anyone's name, it's randomly generated. I have to do this disclaimer because it's a legal software, and we need to protect the client's data. So what do we see in here? We are on cases, and our case so far doesn't have any. My neck will break. This will be easier. Sorry for standing with back to you. But yeah, so far we don't have any special fields available in this case, but we can create a field. We can call it shoe size. We can describe it if we need, We can pick the data type. I think we need an integer. And we will get back to this, but there is one more interesting layer. Currently, we were talking about the content type system, which lets us differentiate between models. There is another layer that will let us differentiate between different types of one single model, which is case. But we will get back to it. For now, we're on a case. We can create this field on a case. And now, when we create a case, when we create a case, where did I put it? Anyone remembers where was it? Wewnętrzne. I think here. Someone needs to be responsible. But when we create this case, we have our own shoe size field, and I'm skipping through some forms to keep it brief. But of course, our shoe size is available under user fields, and we can set our shoe size. For me, it's pretty large, so I think I'm somewhere here. Yeah. And now the client is super happy because they can track their shoe sizes on cases. And of course, the same mechanism goes for contacts, right? So we can go into contacts, and we can see fields on a contact, which is some set of completely different fields. In the system, there are multiple types of contacts because a legal person or natural person is different from a company, which is different from a government office. And all of those are separate models. But due to the content type system, since we store the model name as a string in the database, we can figure out which fields are saved on which model, and thus with the same implementation of user-defined fields, we can apply those fields to multiple different models. So back for more details, now that you have an idea on how this works. Still here? Still here. Okay, so now that you have an idea how this works for the end user, once again going through how it works internally. For saving the UDFs, of course, we use form widgets, and the form widgets run through the normal form clean function, which makes sure that integers are integers and some inputs are not illegal if it's required or not required. Then we need to go through our own internal validator, which contains additional rules. We check for required on this level because in the definition we define if the field is required or not. And we go through our serializer and deserializer to convert the value typed in by the user to string, and then save to the database. And going back from the database, it's the same, just in reverse order. So we start with just fetching the instance, and then we need to look at what the slug of the given field is, fetch it from the dictionary. The HStore is visible as a dictionary. We need to convert it through the deserializer back into Python representation, and then we can use it as a standard field on the model. So a bit more detailed implementation. Sorry. few more implementation details. When we go and get UDF from the database, we need to literally check what the field type is, what the definition of the type is, and the other way around. When we go to a form, so the other way around, when we are rendering the form, we need to go through the definition and use a specific form input to make it look nice for the client. And there is no way around it, whether we use HStore or whether we use JSON-B. I think this code would look exactly the same. We need to define nice widgets that we want to use for every single type of input. And then to inject the fields at the runtime in the form, we of course need to find the UDF definition object that contains the fields specific to a particular model. So to use the UDFs on multiple models, there is some customization required to every single model that it will be applied to, right? So if we want UDFs on cases and on users and on invoices, then we need to customize every single one of those models with some extra juice. And part of this special juice is modification of the forms, where we need to inject the form fields into the forms. And then once we have it stored, we probably want to search or filter the data by UDFs. As I said, it's very well supported by both database and Django. So to filter by a user-defined field, it works just like a relation in Django ORM. So we use double underscore. We provide the name of the column where the HStore UDF is stored, and then underscore underscore, and the name of the field that we want to extract from inside this dict, and then the database is smart enough to use the index, do all the smart things, and treat it pretty much almost like a joined. Like the model was joined with the UDF table, like in the first implementation that you saw. This is almost perfect. Some gotchas that we have, again, with HStore, probably not with JSON-B. This is stored as strings, which means sorting behaves weirdly, and sorting by numbers and filtering by numbers in this way doesn't work as expected, because inside of Postgres this is all strings. So this is a big plus for JSON-B. And nulls, there is a difference. Technically, there is a difference between key value not being there at all and key being there, like a date is in here, but it has no value. There is a small syntactic difference. The nice thing about string comparison is, at least if we serialize date in a ISO format, then the dates work, but numeric lookups are more difficult. Equals works, but less than or greater than is problematic. So how much time do we have? None. Okay, so there is this neat trick. There is a bit more. There is this neat trick if we have two different cases in the system, so two different instances of the same model, and we want different fields on one of the cases, because this one is litigation and another one is bankruptcy. We want different fields, and we also have a mechanism to provide constraints on where the fields should be displayed. So if you're interested, catch me after the talk, and I will be happy to talk about this more. And I don't want to stretch my time, so I will wrap this up. There was a couple of architectural decisions that we made. I would suggest from now on use JSONB, but HStore works really well. No problems with it so far. We need this separate SQL table to define the fields because we want to store additional metadata about who and when created which field definition. For naming, and this is in general, if you can use meaningful names and add randomized part at the end, but for debugging it's super useful. Indexing, we saw how it works, and it's really important if the data will be filtered and queried. It's important to index it in the database. And typing is really important. If the database doesn't support it, build it yourself. It's not a super complicated code. It's just dumping values to string and converting them back from a string. The product impact, this wasn't a super difficult product. It was big-ish, but wasn't super complicated. And there was a huge impact on how the product was perceived by the users. With this, the product is perceived as very configurable and supports every custom flow. Without it, we were struggling with customizations. So definitely worth implementing this if you see a need. Definitely worth investing in it. Yeah, and I won't stretch anymore. I already used all my time. So thank you. If you have any questions, feel free. If we have time. If no, I will definitely be on the after party. So come and join us.
Candy. I can't hear myself. All right. Thank you. Big round of applause. We are out of time, so if you have any questions, just reach out to Szymon after this talk. Now we'll have a switch to another speaker, right? So quick switch, and we'll go with the last talk. Then we'll have a really quick round of lightning talks. So anyone who has a lightning talk, just I see you. Just sit down somewhere here, so you are pretty quick to switch.
O, widzę, że sprytniejszy jesteś ode mnie, więc
tak, bo niestety jest gazowany. Nie
So 1 minute and we'll start with another talk.
No. Czekaj. Podejrzewam, że w ten sposób. Dobra, to zaraz się będę wpinał. To tutaj.
Okay, the last one of the day is in Polish, so I will switch to Polish. Więc to będzie prezentacja o speech to text, czyli jak mówić, żeby był tekst.
Dokładnie.
Brawa.
Cześć. Nie wiem, czy jest ktoś na sali, kto jeszcze nie słyszał terminu vibe coding. A jeżeli ktoś... O, jest tam ktoś. Nie, Dominik. Ten termin został bardzo mocno spopularyzowany przez ten tweet od Andrzeja Karpatiego, gdzie Andrzej pisze, jak on pisze kod w swoich projektach weekendowych, z czego on tak naprawdę nie pisze kodu, tylko mówi, że jak jest w transie, to kod nie istnieje, jest tylko on i komputer i tak sobie gadają i rozwiązują problemy. Brzmi trochę jak odcinek ze Scooby-Doo. Oczywiście nie chcę nic ujmować tutaj Andrzejowi, bo to jest kozak i jego vibe code jest prawdopodobnie lepszy niż mój ręcznie pisany kod. Plus nie chcę tutaj hejtować vibe codingu, bo po pierwsze nie mam na tyle czasu, po drugie jestem konsultantem, więc ten cały vibe code'owy szajs, który trzeba będzie posprzątać, to będzie moja praca za parę lat. Nie. To, co przykuło moją uwagę w tym tweetie, to to, że Andrzej gada z komputerem przy użyciu aplikacji Super Whisper i prawie w ogóle nie dotyka klawiatury. Brzmi fajnie, ale jak to przeczytałem, to nie wydawało mi się, że dyktowanie tekstu do komputera jest ani wygodniejsze, ani szybsze niż pisanie na klawiaturze. To było zanim kupiłem sobie rolki. Poszedłem się przejechać na pierwszą przejażdżkę, wypieprzyłem się i złamałem sobie palca. I nagle okazuje się, że jak macie te dwa palce połączone razem, to piszecie wolniej niż pani w dziekanacie. Więc dyktowanie tekstu wróciło na tapetę. Postanowiłem przetestować tą aplikację Super Whisper. Super Whisper to, tak jak podają tutaj na stronie, mogę, dobra. Jak podałem na stronie, to jest AI-powered voice to... Tak, to przed... Dobra. Okej. Dobra, sorry. Także Super Whisper to jest AI-powered voice to text, czyli narzędzie do dyktowania, przyprawione, tak jak większość rzeczy w dzisiejszych czasach, odrobiną AI. Nie wiem, czy korzystaliście kiedykolwiek z narzędzi do dyktowania tekstu, zanim jeszcze zaczął się ten hype na AI. Ja pamiętam, że dawniej było coś takiego jak Dragon, no ale pamiętam, że był to taki spory software'owy combine, który kosztował kupę kasy. Ja go nawet testowałem, znalazłem wersję studencką na DCQ, a nie było to ani szybkie, ani wygodne w użyciu, więc no, nie przyjęło mi się to za bardzo. Swoją drogą Dragon dalej istnieje i ma stronę tak do bólu korporacyjną, że wydaje mi się, że jak chcecie anulować subskrypcję, to trzeba wysłać faks do Nowego Jorku. Także no, nie zachęca. Więc do Super Whisper podchodziłem trochę z pewną dozą sceptycyzmu, ale stwierdziłem, kosztuje to $8, więc jak mi się nie spodoba, to po miesiącu przestanę płacić. A w ogóle wersja darmowa ma jakoś 15 minut transkrypcji w tych modelach Pro, więc zawsze można to trochę przetestować. Jak działa Super Whisper? Naciskamy sobie jakiś skrót klawiaturowy, u mnie to jest Ctrl i ten backtick. Zaczynamy gadać do komputera, naciskamy ten sam skrót klawiaturowy, czekamy chwilkę, no dosłownie jak mamy do transkrypcji 1-2 zdania, no to czekamy mniej niż sekundę. Jak mamy jakiś dłuższy paragraf, no to czekamy 2-3 sekundy. Nie jest to długo i potem nam się wkleja tekst w miejscu, gdzie jest nasz kursor, czyli jeżeli ustawimy kursor w miejscu, gdzie chcemy wkleić ten tekst, to się od razu wklei. Jeżeli na przykład chcemy go wkleić gdzie indziej, to ten tekst też nam się automatycznie kopiuje do schowka, więc jest to dosyć wygodne. Jeżeli coś źle powiemy, chcemy zacząć od początku, no to naciskamy Escape. Możemy też wybrać sobie różne modele. W przypadku Super Whisper mamy jeden osobny model do samej transkrypcji i osobny model do postprocesowania tego, co powiemy. Czyli w przypadku postprocessingu możemy sobie wybrać model, który będzie nam usuwał te wszystkie ale możemy też wybrać sobie troszeczkę bardziej zaawansowany model, na przykład jeżeli chcemy robić jakieś notatki ze spotkania, to ten model, jeżeli na przykład coś wylistujemy, to ten model spróbuje nam z tego zrobić listę w tekście i tak dalej. Także jest parę różnych modeli, którymi się można pobawić. Mi Super Whisper sprawdził się bardzo dobrze do dwóch rzeczy. Przede wszystkim do pisania z ludźmi na czacie. Do dzisiaj z tego korzystam, bo mam layout klawiatury Mac, który jest super do pisania po angielsku, troszeczkę gorszy do pisania po polsku, więc jak nie chce mi się za dużo pisać, to po prostu sobie dyktuję. Oraz do robienia notatek, jak robiłem research do kursu online. To też działało świetnie, bo czasem sobie trochę pisałem, czasem sobie dyktowałem. Podobała mi się ta idea, że mogę sobie, nie wiem, coś przeczytać, coś przemyśleć, gapić się w okno i równocześnie dyktować rzeczy do komputera, więc to było fajne. I to było fajne dlatego, że nie zależało mi na tym, że to, co zapiszę, żeby było super poprawne, bo po prostu chciałem gdzieś zapisać swoje myśli i te zdania nie musiały być super idealnie skonstruowane. Bo na przykład jak piszę maila, to też czasem go dyktuję, ale wtedy muszę przeczytać sobie cały ten tekst i popoprawiać te rzeczy, których ja osobiście bym nie napisał w mailu. No ale po jakimś czasie przestałem robić kurs, palec mi się zrósł, więc mogłem używać wszystkich palców do pisania i prawdę mówiąc przestałem korzystać z tego Super Whispera tak często. No i wtedy okazało się, że płacenie $8 miesięcznie nie kalkuluje mi się, bo $8 to $8. Więc zacząłem szukać alternatywy i okazuje się, że jest bardzo dużo różnych alternatyw. Jest kupa takich narzędzi i one wszystkie działają podobnie. Mamy Whisperflow, mamy Mac Whisper, mamy VoiceInk i całą masę klonów i widzę, że dalej powstają kolejne klony. Ja zacząłem od przetestowania Mac Whisper. Testowałem wersję darmową i w końcu nie szarpnąłem się na kupno wersji Pro. Jakoś mi nie podszedł. Nie wiem, może wybrałem zły model, może coś było nie tak, ale za bardzo zmieniał to, co mówiłem. Znalazłem potem VoiceInk i w sumie z tego korzystam do dzisiaj. On kosztuje $25 jednorazowo. Ja kupiłem go troszkę taniej. No, aplikacja jak każda inna. Za chwilę powiem troszeczkę więcej szczegółów, no ale jak kupicie jakiś tańszy klon, też będzie działał dosyć podobnie. Bardzo dużo zależy od tego, jaki model sobie wybierzecie. Większość tych aplikacji wygląda podobnie. Dają wam dostęp do różnych modeli. I czasem możecie chcieć model, który troszeczkę bardziej zmienia ten tekst, który mówicie, czasem taki, który mniej zmienia. Funkcje tych różnych programów do dyktowania tekstu są podobne. Naciskacie jakiś guzik, dyktujecie tekst, wkleja się wam ten tekst. Super Whisper miał fajne coś takiego, że możecie sobie zrobić własny słowniczek z terminami, których używacie w pracy, czyli jakieś skrótowce, jakieś słowa, które są charakterystyczne dla waszej dziedziny i wtedy jak dyktujecie, to Super Whisper wam nie próbuje zamienić słów na jakieś inne, tylko wie, że takie słowa naprawdę istnieją. Jeśli chodzi o tego VoiceInka, to on oferuje całkiem sporo modeli. Niektóre działają lokalnie, niektóre działają w chmurze. Lokalnie mamy właśnie dostęp do tego wbudowanego applowskiego text-to-speech, mamy Parquet w wersji 2, wersji 3, jakiś model Tiny, Large i tak dalej. Jest też kupa modeli w chmurze, które działają poprzez podanie tokenu API. No i za to płacicie. Podpinacie sobie swoje API i korzystacie z Google'owego, z Eleven Labsowego, jakiś DeepGram i tak dalej. Ja na początku próbowałem korzystać z modeli lokalnych, ale nie mam jakiegoś takiego potężnego komputera, więc średnio mi się to sprawdzało. Tylko to było jeszcze zanim wszedł Parquet. Teraz widzę, że Parquet działa całkiem dobrze, także polecam. Ja zacząłem korzystać z modeli płatnych i pierwsze pytanie, które mi się nasunęło, to ile za to zapłacę? Nie chcę, żeby się okazało, że przestałem płacić $8 miesięcznie za Super Whispera, żeby dostać rachunek na $80 od Google, bo gadałem do komputera przez godzinę. Okazuje się, że to nie jest drogie. Dla mojego bardzo sporadycznego używania przez 4 miesiące modeli Gemini 2,5 Fast oraz Pro zapłaciłem 4 zł. Więc spokojnie można sobie dodać klucz API, ustawić sobie jakiś limit i przetestować. Tak jak mówię, używałem Gemini przez 3,5 miesiąca, a potem zaczął mnie trochę denerwować, bo za bardzo edytował to, co ja mówiłem. Ja chciałem, żeby on tylko usuwał te wszystkie a, e. On tam zaczął zmieniać ten tekst, który ja mówiłem. Więc zacząłem szukać sobie czegoś innego i widziałem, że w VoiceInku ten model Scribe od Eleven Labs ma największą skuteczność niby. Więc stwierdziłem, że go przetestuję. Przesiadłem się na Scribe'a i jak się okazuje, jest tam wersja darmowa, gdzie macie 10 000 kredytów miesięcznie. I tutaj jest moje zużycie po 2 tygodniach używania. No, zużyłem 20% tych darmowych kredytów, więc spokojnie mieszczę się w tym darmowym limicie. Swoją drogą, ja nie jestem związany z żadnym z tych narzędzi, to nie jest reklama, tylko mówię to, czego używałem. Jak na dzisiaj mój setup to jest Voice Inc. i Scribe w wersji pierwszej. Koszt miesięcznie wychodzi 0 zł. No, musiałem zapłacić za tego Voice Inc.a, ale teraz nie muszę nic płacić. Jak w ogóle wygląda skuteczność tych modeli? Stwierdziłem, że zrobię sobie porównanie. Przeczytałem to, co jest na stronie Django REST Framework. Mamy tutaj nazwy technologii, mamy tutaj skróty, więc nie jest to najłatwiejszy tekst do transkrypcji. Więc nagrałem się, jak czytam ten fragment tego tekstu, zaznaczony tutaj, i potem przepuściłem to przez różne modele. Tutaj mamy tak, na górze mamy oryginał skopiowany po prostu ze strony, na dole mamy to, co nam wypluł Super Whisper. Widzicie, troszeczkę się to różni. Żeby było łatwiej, zrobiłem diffa. I tutaj tak, na górze jest oryginał, na dole jest Super Whisper. No, pierwsza rzecz, która się rzuca w oczy, to tam mieliśmy bullet pointy. Tutaj Super Whisper wypisał te rzeczy po przecinku. No, te modele nie wiedzą, że coś jest listą, więc tego nie przeskoczą. Całkiem dobrze sobie dał radę. No, w przypadku OAuth 1 zgubił, tutaj jest 1A, tutaj zgubił to 1A i wstawił spację. W przypadku dwójki no też wstawił spację, ale większość się mniej więcej zgadza. Tutaj mamy Scribe'a, który troszeczkę lepiej sobie właśnie poradził z tym OAuth 1A, nie zgubił tego A. No i większej różnicy tutaj nie ma. A tutaj mamy Scribe, ale z jakimś assistant prompt, więc w Voice Inc. możecie sobie wybrać prompt. Jest tam jeden domyślny, a drugi jest niby asystent, więc podejrzewam, że jak zmienicie prompt, no to on się nastawia bardziej na to, czy to są jakieś notatki ze spotkania, czy to jest właśnie jakaś rozmowa, czat, czy coś takiego. Jest tutaj różnica, tutaj mamy spację między 1A a OAuth, ale podejrzewam, że to wszystko wynika z tego, że te rezultaty są niedeterministyczne, więc jak przepuścicie to samo nagranie przez model, to troszeczkę może wyjść inny rezultat. Tu mamy Gemini wersja 2,5 Pro. Totalnie nie dał sobie rady z czymś z OAuth 1A. Jest po prostu OAuth 1A, OAuth 2, więc no to mu trochę nie siadło. No, Resta też nie, w porównaniu do innych modeli, Resta też nie wiedział, jak to zapisać. To powinno być z wielkich liter. Ten sobie tutaj nie dał troszeczkę rady. No tak jak mówię, Gemini 2,5 nie jest najlepszy do tego. Parkiet, czyli model lokalny, za który nie trzeba płacić, też dał sobie radę. Bardzo podobne rezultaty do Super Whispera. Testowałem jeszcze Large VT Turbo, czyli jakiś model, który sobie ściągamy i odpalamy lokalnie. Zawiesił mi kompa, więc no, wyników wam nie podam. Próbowałem przetestować też wbudowany Apple Speech, ale nie mam najnowszej wersji macOSa, więc też powiedział, że ale testowałem ten Large 3 Turbo i Apple Speech kiedyś w przeszłości i pamiętam, że one nie były jakoś tak super dobre. Plus Apple Speech nie rozpoznaje języka polskiego, to też jest pewien minus. Wróćmy jeszcze na chwilę do tego modelu Scribe'a, którego używam. Jak już wspominałem, w tym planie darmowym macie 10 000 kredytów co miesiąc, co na pierwszy rzut oka nie mówi wam zupełnie nic, bo ile to jest 10 000 kredytów, na ile to starcza. Też postanowiłem to porównać. Przeczytałem inwokację z pana Tadeusza, bo to jest coś, co pewnie większość z was zna. Inwokację znalazłem tutaj na stronie. I tutaj jest na dole tekst inwokacji. O Jezus, nie ten guzik. Też nie ten guzik. Oj, idę w tył. Na dole mamy tekst inwokacji, na górze mamy to, co wypluł mi Scribe. Jest to bardzo podobne. No, są pewne różnice, jak widać Mickiewicz nie znał ortografii, znaczy gramatyki tak dobrze jak Scribe, czyli ty z małej litery po wykrzykniku. Tutaj jest gdzieś gdy z dużej litery w nawiasie, także Scribe trochę lepiej radzi sobie z polskim niż Mickiewicz. Jedna główna różnica to jest tutaj przywróciłaś versus powróciłaś. Także to jak dla mnie dosyć dobre wyniki. Czas czytania tego zajął mi minutę 14 sekund i zużyło mi to 80 kredytów. Inwokacja ma 145 słów, ale nie ma to zupełnie żadnego znaczenia, bo jeśli chodzi o scribe'a, to liczy się czas, przez ile on robi transkrypcję. W tym darmowym modelu mamy 2 godziny 30 minut, czyli no, jak mi to wystarczy przy takim moim sporadycznym zużyciu. Jakie wnioski? Większość narzędzi jest bardzo podobna. Jeżeli ten Voice Ink jest podobny do Mag Whispera, który jest podobny do kupy innych klonów. Także jak szukacie sobie jakiegoś takiego narzędzia, potestujcie parę. Jeżeli znajdziecie jakiś feature, który wam się bardzo spodoba, wybierzcie to narzędzie. Jak nie, to wybierzcie to tańsze. Prawda jest taka, że najlepsze rezultaty zależą od tego, jaki model podepniecie. Lokalne modele dają radę, Parkiet daje sobie bardzo dobrze radę. Im mocniejszy macie komputer, tym podejrzewam, że lepsze modele możecie sobie podpiąć lokalnie i nie musicie płacić. Płatne modele nie są aż takie drogie, jak myślałem. Myślałem, że będzie to droższe, wcale nie jest. Także osobiście, dopóki używam mniej niż $8 kredytów miesięcznie, no to używałbym raczej po API. Jakbym znowu pisał coś więcej, dyktował coś więcej, to podejrzewam, że wróciłbym do Super Whispera. Tutaj taki mały tip geograficzno-podatkowy. Jak kupujecie oprogramowanie online i ostateczna cena wam się nalicza przy checkoutie, w zależności od tego, jaki kraj wybierzecie, to zależy to od VAT-u. W Polsce VAT jest 23%, w Monako VAT jest 0%. Kto to sprawdza? Nikt. Także nic nie sugeruję. Zrobicie z tym, co chcecie. I to tyle. Nie wiem, czy mamy czas na jakieś demo. Jak nie mamy czasu na demo, to mam Lightning Talka pewnie. Mamy czas na demo? Okej, no to mogę wam pokazać w sumie, jak to działa. Sekundkę.
W międzyczasie może jedno pytanie.
Jasne, dobry pomysł, pytania.
Czy próbowałeś używać któryś z tych modeli do programowania albo jakichś takich innych zadań technicznych?
Nie. Stwierdzam, że do programowania to by było straszne. Myślałem nad tym, ale nie wyobrażam sobie dyktowania programowania za bardzo, także nawet nie próbowałem. Mirroring, czekaj, kurczę, hej. Wiem, tylko ucieka mi cały czas ten... No, ciobągu. Dobra, zrobimy inaczej. Wypnę cię. To zawsze działa. O, dobra. Dobra. Widać to, widać. Zobaczmy, czy to w ogóle będzie działało. Hej, jak mnie słyszysz? Czy dasz radę to przetłumaczyć? Okej, działa. Spróbujmy sobie jakiś może dłuższy tekst tutaj wkleić i... Proszę? Wolę nie próbować. Dobra, to zobaczymy, jak mu idzie generowanie tekstu. Trochę dłuższy paragraf. Now we will see if he can actually recognize English and maybe just to bump the difficulty. Je m'appelle Claude, je suis polonais, j'habite à Cracovie. To będzie ekstra trudne, bo mój francuski się. Dał radę, bez problemu. Bez problemu się przerzucił na angielski w trakcie. Mój tragiczny francuski też tam dobrze poszło. No tak to działa. Jak widzicie, dobra. Dosyć szybko jest w stanie podłapać i zrobić transkrypcję. Jedyny problem czasem jest taki, że utnie mi to, co mam na początku, więc albo głośniej mówię sam początek, albo po prostu daję mu chwilkę przerwy. Raz, dwa, trzy. No. 3 sekundy. Dobra, nie wiem, myślę, że wystarczy. Tak to wygląda. Jak macie jakieś pytania, oczywiście będę też na afterze, także zapraszam.
I to jest bardzo dobry powód, żeby dołączyć do nas na after. Wielkie brawa. No dobra, to switching to English, let's go with really quick lightning talks. Come on, guys. Let's start with you. And we'll be switching one after another quickly.
Yes, good. All right. So it's going to be a non-technical lightning talk, but please don't leave the room. My name is Timoteusz. I was also studying here back in the past. And I'm going to talk about Japanese alphabets. I'll try not to make your Western brains explode. So the whole concept for this presentation started October 2024. It's already some time ago when we went to Japan. It was a great trip. So in Japan, you have many, many amazing things. But the thing that caught my attention the most were Japanese alphabets. So there are so many great, interesting signs that I was just fascinated by that. And in the space, there are lots of long words. Like cities have very long numbers of characters there. But there was one city, Osaka, where we traveled, and it's just 2 characters. So as you can see, the first one and the mix over there. And I thought it must be something unusual to have a whole city use just 1 characters for the word, especially that the first character was one of the simplest that I saw in the public space. So I wanted to check this out, and it turns that Osaka means large hill in Japanese. O, so the first character is big, and I thought that it really makes sense because the character looks like a person stretching their arms and legs wide, showing that something is really big. And I might have stopped my journey there. When I reached the room, I used one of these, famous Japanese toilets, and my learning could have stopped there, but when I was about to flush, I saw this on the handle. So one side for a big thing, one side for a small thing. And I stopped for a second, and I thought by just learning one simple character, you can actually get something useful. So I went to explore a little bit more. I'm not going to get into details, but basically you have lots of writing systems in Japan. You have those that are called logographs, mainly kanji. So each character is a word or a meaning, not a sound. So for example, this one is a mountain, this one is a tree. You can see my cursor, great. And then you have the ones like hiragana, katakana that are existing and they represent sounds, just as our alphabet. And yes, they are mixing those. All right, lesson 2. As I told you, maybe I'll go back. As I told you, for kanjis, there are 50,000 of them, but they say that to read a newspaper, you just need around 2,137 or something. But for more newspapers for specialists, you need more. All right, so you know the meanings of the kanjis, but now lesson 2 is combining them. So you can add one to another. So as I told you, the second one means a mountain, and the first one means fire. And when you put them next to each other, that means volcano. So Kazan means a volcano. You can go further, so you can combine multiple characters into one. So as you can see on the left, this one stands for rain, this one is rice paddy and umbrella, and if you mix them all together, it's a new one character, it means electricity. And you can play this game on and on and on to use both techniques, so stacking the characters together and putting next to each other. So for example, this one is a nuclear power plant, and as you can see, there is electricity from the left over here. So I don't know what's the reason for all those words here, but it makes sense for someone. All right, and then it goes on and on and on, because as I said, there is more than 50,000 of them, and eventually you want to read some of them. And the problem is there is no one simple system, so you just need to know the word, and you need to know the context, and you need to know the reading, right? What's more, for all these 50,000, or at least the basic ones, there are different types of reading. So it's not that one character can be read just one way. There's a Chinese way, there's a Japanese way, so even Japanese people get lost at some point, and they have this help to read sometimes. All right, so going to the end, what I want to suggest, and what I wanted you to leave this talk with, is not to start learning Japanese, because it's going to be a long journey, just to know how to read the code of your Japanese friend. But the keynote is, sometimes, even if you just learn one simple character, one simple letter, it's going to help you eventually in some certain situations, as me. Thank you very much.
Thank you. Next one. Then we'll have, who's next? Okay, you can be next. Okay. We're moving swiftly with this one. Okay.
Okay. Hi, everyone. I wanted to say a few words about immutable dicts in Python. Maybe a quick background. I was having classes on Python, and I was asked to write functional-ish code for this task. So I decided that I will go for fully functional code in Python. So I needed some way to store data, and preferably in immutable way. And we have list and tuple as a pair of mutable and immutable. We have set and frozen set. And for dict, I didn't know about immutable type for this one. So I Googled it, and there was a PEP to add it, like a frozen dict. But it was rejected. And one of the reasons was that there is already something that should give us this feature of immutable dicts. So we have this mapping proxy type, which, as you can see, it pretty much works like like we would expect, you can write to the dictionary under the proxy mapping, but other than that, you can't assign anything to values to this mapping. And it's actually used when you use dict attribute of any class. So it's actually used by built-in functions and features in Python. So we could assume that it's an immutable dict. But there is, oh yeah, okay, maybe let's skip this to get, we don't have time. There is one issue. When we want to serialize it, there's an error, and it says that a mapping proxy is not JSON serializable. Okay, so why not? The first reason is it's not backward compatible. Yeah, that's very great. So as you can see, if someone wrote that code and we would add a way to serialize it, then it's not backward compatible. So we can't add it, and actually devs spoke about it, and they think that it's, even if it's code that doesn't work, it's whatever, we shouldn't add it to Python. And the second reason is the semantics of mapping proxy, and what does it actually do, this mapping proxy type? Why is it named like this? So it's actually something that gives us all the features of dictionary except writing to it. That's how it's done in CPython under the hood. So you can't change any value, but you can do anything with this the same way you would do with dictionary. It also doesn't create a copy of this dictionary, so that's why it's called the proxy. And if we could serialize it, this line, the last line would have like no meaning, because you wouldn't have another. You can't just get back this dict back into the variable. So it's not an immutable dict. There is the definition that it's read-only view of a dictionary, and that's funny because if you remember the rejection of adding a frozen dict, it actually said that we already have something like immutable dicts in Python. So there's a little bit of inconsistency here, in my opinion. There is open pep that would add frozen map, not frozen dict, and but it's still like in process of reviewing. And that's all. Thank you.
And now the next one. Maciej, get ready.
Może mnie ktoś inny. To nie robisz next time.
Lightning freeze. We'll get back to this one.
Okay. So I have very quick, very quick lightning talk. I don't think even it will be less than 5 minutes, more like just show and tell. So I just wanted to share with you updates on AI front when it comes to research. I have two cool papers that I wanted to show you. One is adversarial poetry as universal singleton jailbreak, meaning these researchers have came up with novel way to jailbreak LLMs, apparently. This is very fresh research, so this is 20 November, so very fresh. So it might not be like peer reviewed, and this comes from arXiv, so take it with a little bit grain of salt. But what they claim here is that with their method, and I'm searching for a graph here. Yeah, what they're claiming that using their method, they were able to pretty much jailbreak Gemini 2.5, DeepSeek with this accuracy. And those are, you can see large percentages because those people are handcrafting those examples. And you may ask, how do I make an example like this for myself? Well, to answer that, they are not answering that directly, but they give us a poem about this. And they are not sharing exactly how they do this. So there is this poem that more or less describes what they are doing. I tried a little bit reproducing the results and had a problem with it. So it might not be like super actual or factual. And the other one is also from AI. Language models are injective and hence invertible. This is very cool paper. Also, that's quite fresh, yet still I didn't hear anything about reproducing this research, so still take it with a grain of salt. You can remember this whole paper by this Pringle-like shape, but what they are showing here, and what it is about is that when you have text and convert this text into embedding, so a vector just before we have just a token, you can convert back the embedding to that text with nearly 100% accuracy, which for security reasons, I think it's a big thing because people used to think that you can, when you have embeddings, that's pretty much like hashing the stuff and you cannot decipher it back. But apparently it's doable. And they also show research. In their research, they show like the real life time of conducting their method to reconstruct the embedding. And to reconstruct one embedding, they do it in 30 seconds with like a more or less normal graphics card and more or less setup that you can have in your lab. But what is also interesting and fun about this paper is usually people have big issues with sharing, like deciding who is contributing or who is the first author, who is the second. one. And this one is quite cool. You can see that those two guys are first two authors, but they have a little star here. And let's check what that means. In that case, it means equal contribution, author order settled via Mario Kart. And that's it from me. Thank you.
Thank you.
Test. Can I see my screen? Yeah, hey, I'm disconnected. I'm going to talk about some cool tools in the web. Question first, who used any of those tools? Raise your hand, please. Okay, cool. Some of you did. So for example, there's the JSON formatter, and it looks like that. If you paste in here some JSON, you can then validate it or format beautify. It looks nice, right? And there are many, many other tools like that in the web, and I'm not going to show you those tools because that's boring. What I want to show you is that some of those tools have cool features, like save online feature. Well, the question is, if you save online, you get some random link, right? But then the question is, can anyone with the link get the data? Well, the links are randomized, right? Right? Well, that's one thing. Second thing is that if you look here and open your network tab and like enter this page, you can see pretty much a lot of network going on here. Like, what the fuck is that? Why there are so many requests? Well, probably because of all those advertisements here. As you can see, I didn't enable any ad block here, but basically, this means that there are so many JavaScripts running on it here and like sending some kind of data to some kind of servers, which can also be your data that you put here, right? Because who validates this JavaScript that comes from the advertisers? Well, I don't, but do you? Yeah, so this lightning talk is motivated by this article, stop putting your passwords into random websites. And basically, you are the problem in here. And the site we have seen is one of the random websites, right? And they did a research on those websites, and they found that they could like download more than 80,000 submissions that were there, and that's where they stopped downloading more. They downloaded like 5 years of historical data on JSON formatter, 1 year of historical data on Code Beautify. It was more than 5 gigabytes of data in total, and a lot of secrets. A lot of secrets. Do you know what this means? Well, it means API keys and other stuff. And well, how do you get valid IDs? Well, of course, there are recent links on some of those websites. So for example, here, a recent link is like 6 random characters. Not a lot, right? It's probably less than 6. It's probably 3 bytes hex encoded. Yeah, whatever. Anyway, so those were the URLs they have checked for those websites. And here's like an example. Like they found, for example, a access token for Jenkins and the username, some Docker stuff, and a lot of more, actually. They have more examples on their article. And they basically found that there are like more than 350,000 safe uploads since the inception of JSON formatter, at least on that website. I'm not sure about the other ones. And they also told people before they went public with it, right? Because this article actually popped out like 2 days ago. And they contacted the CERT teams, which is like community emergency response teams in different countries, and yeah, even in Poland actually. And they also contacted CISA and some other centers for cybersecurity. And also they attempted to contact affected organizations. Some of them responded, but not many. So they have this kind of graph that security teams that didn't respond to us. Yeah. So the question is how to live. Well, we are humans and we are smart. Can we fix that? Obviously we can. We can have offline first applications, but the web that we have today doesn't allow for this, which we'll see in a second. Yeah, we can write websites in JavaScript or WebAssembly, so we can have pretty much powerful applications that will work on your single page without doing any kind of external requests. because you can do WebAssembly, so you can do pretty much a lot of stuff, even like, I don't know, parsing like huge files, or having something like MATLAB, maybe MATLAB in web, I'm not sure, but something like Autodesk is probably there in WebAssembly. But we cannot have some kind of solution where we would limit external requests from a given website from a given point of time. And if we had such a feature, we would also need some user experience or user interface for that, so that the user knows that, hey, from this point of time, if you provide something here, this cannot leak anywhere. One thing, there is this content security policy header that is pretty much useful to this, but it doesn't provide all these features. Because first, if you provide a content security policy, it limits what the website can do, like it maybe cannot load any images, for example, or JavaScript, but you cannot modify the CSP afterwards. So you need to preload something first and only then limit it. Yeah. So maybe we can suggest this to browsers as a feature request. Well, probably. I don't know. I haven't done it maybe yet. But that's it. And well, stop putting your passwords into random websites. Thanks.
We can do lightning talks to the point where Gwen won't turn off everything.
Good. Okay, we had a lot about LLMs today, so I will add also something from me. Non-obvious uses of LLMs, but beyond answering the questions. So did you know that you can generate code with LLMs? But yeah, you can. Not funny joke. But LLMs are better at explaining code, in my opinion, at least, because they can read fast a lot of data, and they can catch what the user wants from this data. But you can also generate a draft of a presentation like this one, if you have your presentation in Markdown, the favorite language of format of LLMs. But also you can filter the trash, but not this one, the data trash, the internet trash. And I had a very specific use case of LLM some time ago. And apparently it's a funny use case, as I discovered during one of the after parties. So in my case, the trash was the OLX website and tons of advertisements there. And I was looking for a wardrobe, but very specific one. So I didn't want to browse through all of them because I wanted the one on the right, I had the one on the left. So I needed to find a wardrobe that was taller, higher. So instead of going through all of the advertisements and read the description, because nobody puts the size in the description, in the title, sorry, I invited Windsurf plus SWE1 model, their in-house model, which is free. And I used Playwright, MCP, to filter the trash. And this was the code, I mean prompt. So basically I told the LLM to scan the website, extract all the URLs and iterate over them. And here is small result, but yeah, you can see how the LLM basically iterated over the page. And this was the result. So again, Markdown report that just showed me the URLs that contained interesting offers. And I had one more thing, but I was promised a beer if I fit under 3 minutes, so that's it.
You will say it at the after party, right?
Okay, so yeah, as you can see, we'll have a very deeply technical lecture about how to hack anything under 15 seconds. So, for example, for the alarm systems, these are two true stories that I had that I have to tell you. In a company that I used to work, we had an alarm system that looked like this one, and to arm the alarm before leaving, we had to input four numbers and press the button at the bottom right. Quick side note: do you know how it is called? What's the name of this character in English? I see we have British people in the audience, but I'm not talking about the traditional English, but the simplified one. So, do you know how it's called? Thank you. No, it's not hashtag. It's the hash character, because that's the hash, and this is a tag that is denoted by a hash, hence hashtag. So that was a side note. So anyway. The way to arm was to input 4 characters and then press the hash button. And we were 2 people, which was me and someone else. We were left at the company, and we wanted to leave. I wanted to leave in a hurry, so I wanted to hurry the guy. So just to mess with him, and also to make sure that I don't do anything stupid, I did something stupid because I just pressed 1, 2, 3, 4, 5 hash, and the alarm started going beep beep, beep beep, beep beep. Okay, something's wrong, because first thing is that it was supposed to give one single long beep if it were armed, but yeah. So I was like, okay, I did something wrong, and. Well, we didn't know what to do, so we called the number that we are supposed to call when the alarm goes off accidentally, for example. And the coworker just talked to the guy. Okay. He input something, and the beeping stopped. And then he turned to me and he said, "Łukasz, congratulations, you found our service code." So, yeah, I guess. So yeah, 15 seconds and I hacked it. The second story is about how to hack any Android phone, again, under 15 seconds. That was at a different company. I was with a coworker. We were working side to side, and he left his phone between us. So just to mess with him, you can see a pattern, but I promise that I'm friendly at work. So just to mess with him, I took the phone and I started, pretending that I was unlocking it. So my plan was to, do this, then do this, then do. Oh, oops. And the coworker was like, "Give me my phone back." Okay, so I guess I found a second maintenance code. Yay. So in conclusion, well, what's the conclusion of this talk? Well, it depends on your feelings when you were watching it. If it amused you and gave you a chuckle, that's good. But if it made you uncomfortable, then maybe, just like me right now, you really should change the pattern. Thank you.
Okay, that was the last one of the day. So, Pykonik comes to an end, almost, because we still have after party. Who's going? Great, all of you. Quick round of applause. Oh, what's that? It's not working. I know why it's not working. It's the last slide. Okay, quick round of small applause, like one clap for each partner we had today with us. deployed. JetBrains, Bit and Kernel, CLUG. Yay. All right. Discord. If you are there, that's great. If not, join us, discord.pykonik.org. Now the competition. Oh, I haven't. Whose phone is this? It's not mine. How to unlock it? Let me quickly check, but before I do this, we go to Filutech in a minute. Okay, guys. The winner of the prize today is Łukasz, who's online. Do online count too? I don't remember. They don't count. So the second one is actually Emmy. You take the code, you take the license, you seem like you do. Round of applause. Okay, and that's it from me today. Actually, I'm Evelio on the Discord, so if you have any comments, feedback to us, you can catch me there too. Thank you for today. Let's go to the party and have fun for the rest of the night. See you next time.